Division might look like a simple operation, but behind the symbols lies a specific idea. Division is about the process of splitting a quantity into equal groups. When we write 10 divided by 2 equals 5, we're not performing magic. We're simply asking a question. So, if 10 objects are separated into 2 equal groups, how many objects will each group contain? The answer is 5. That means division is deeply connected to grouping. It actually tells us how quantity distributes when shared equally. There is another way to understand division. Division is the inverse of multiplication. When we write 10 divided by 2 equals 5, we're also saying something else. 2 multiplied by 5 equals 10. So this relationship is always true. If a number a divided by b equals c, then multiplying b by c must return a. So this connection between multiplication and division is one of the foundations of arithmetic. It actually allows us to check answers and solve equations. Now imagine something interesting. Instead of dividing by 2, we begin dividing by smaller numbers. 10 divided by 1 equals 10. 10 divided by 1 half equals 20. And 10 divided by 1/10 equals 100. 10 divided by 100 equals 1000. Something surprising begins to appear. As the number we divided by becomes smaller, the result becomes larger. This pattern continues, so the closer the divisor moves towards 0, the larger the answer becomes. So this growing behavior suggests something very dramatic. The result appears to increase without limits. In mathematics, numbers that grow without spawn are said to approach infinity. From this pattern, it may feel natural to jump to a conclusion, because if dividing by smaller numbers produces larger answers, then dividing by 0 might actually seem like it should produce the largest result possible, infinity. But mathematics is extremely careful with its definitions. Patterns alone aren't enough, because every operation must remain logically consistent, and this is where dividing 0 begins to cause serious problems. Remember the relationship between multiplication and division, because if 10 divided by 2 equals 5, then 2 multiplied by 5 must equal 10. Now, imagine we try to apply the same rule to dividing by 0. Now, suppose we claim that 10 divided by 0 equals some number. Let's call that number x. According to the rules of arithmetic, that statement would imply something else, because 0 multiplied by x must equal 10. But here, the logic immediately collapses. Now, 0 multiplied by any other number produces 0, and 0 times 1 equals 0, and 0 times 10 equals 0. 0 times 1 million still equals 0. So there is no number in existence that can actually make 0 multiplied by something equals 10. Because of this, the equation has no solution. Since no number can actually satisfy the equation, mathematicians make an important decision. Instead of forcing an answer, they declare the operation undefined. Now, undefined does not mean the answer is 0. It doesn't mean the answer is infinity. It means that the operation simply has no valid result within mathematics. So this protects the logical structure of arithmetic. Without this rule, contradiction will appear everywhere. To understand how dangerous divided by 0 is, imagine if mathematics allows it. Equation could begin producing impossible conclusions. With a few algebraic tricks, it could become possible to prove statements like 1 equals 2. Number will lose their meaning. Equations used in engineering, physics, and computer science will become unreliable. Entire scientific systems depend on mathematics for being internally consistent. Allowing divided by 0 will actually break that consistency. There is one final subtle idea. Numbers can actually get closer and closer to 0 without ever reaching it. For example, 1/10, 100, and 1000. When we divide by a number like this, the result grows larger and larger. So this behavior is studied in mathematics using limits. A limit describes what happens as a number approaches a value. But approaching 0 is not the same as reaching 0. The moment the divisor becomes exactly 0, the rule collapses. The operation stops being defined. Division helps us to understand how quantities break into equal parts. Multiplication helps us to understand quantities from repeated groups. Together they form a balanced system, but 0 sits in a very special place within that system. It behaves differently from every other number, and when division tries to interact with 0, the operation stops making sense. So that is why mathematics does not allow division by 0, not because mathematicians dislike the idea, but because the logic of number demands it. If you like this, make sure you like and subscribe for more, and I hope to see you next time.